Have you ever wondered what it would be like to look up and see a giant, spectacular ring stretching across our sky? Well, today, we're going to dive into the incredible and frankly terrifying physics of what would happen if our moon got just a little too close enough to be torn apart, giving Earth its very own set of rings.
I mean, just look at that. It's a stunning image, isn't it? But the story of how our planet could end up looking like Saturn, well, that's a pretty dramatic tale of a gravitational battle to the death.
And here's the thing. This isn't just science fiction. This whole idea is grounded in some really powerful physics. It's a story about a gravitational tug-of-war, one so intense it could literally rip our closest celestial neighbor to shreds and transform it into something both beautiful and terrifying.
Okay, so before we get too carried away, we have to do a quick reality check. Right now, in our actual solar system, tidal forces are pushing the moon away from us at about 4 centimeters a year. So for this whole scenario to work, we have to imagine something has reversed that process, sending the moon on a collision course with a very specific and very dangerous cosmic boundary.
Right, that cosmic boundary I just mentioned, it actually has a name. It's an invisible line in space that marks a point of no return. And it's this line that governs the fate of moons all across the universe.
It's called the Roche limit. And you can think of it like this. Earth's gravity pulls on the side of the moon that's closer to us a little bit harder than it pulls on the far side. That difference creates a stretching force, a tidal force. Now, if the moon gets close enough, that stretching force becomes stronger than the moon's own gravity that's holding it all together. And that's when it starts to break apart.
And here's where it gets interesting. The Roche limit isn't just one single line. If the moon were, say, a loose pile of rubble, what scientists call a fluid body, that danger zone would start way out at around 18,400 kilometers. But since our moon is a solid, rigid body, it could actually get a lot closer, to about 9,500 kilometers, before Earth's gravity would finally win that tug-of-war.
And you know, it's even more complex than that. The exact point of destruction really depends on what the moon is made of. A strong, rocky body can handle way more stress than a loose pile of cosmic rubble. If it has a dense core, like our moon does, its outer layers might peel off first. Even its speed and its spin play a role in this whole cosmic dance.
So what does this tearing apart actually look like? If you're picturing some big, instantaneous Hollywood-style explosion, think again. The reality, according to the physics, is a much slower, more methodical, and honestly, an absolutely terrifying unraveling. So first, as the moon gets closer to that limit, it would be stretched into this weird, elongated, egg-like shape. Then, its outer layers, the crust and the mantle, would start to peel away, almost like the layers of an onion. After that, material would literally erupt from both the near side and the far side, until finally whatever's left just completely shatters into a massive cloud of debris.
So yeah, there isn't just one way this whole thing could go down. Because our moon has that dense core and a lighter mantle, it might go through something called mantle stripping. That's where the outer layers form the rings, but the core might actually survive for a little bit longer. The other option? Complete fragmentation. The whole shebang just gets obliterated into debris all at once.
Okay, so let's move on to the next phase. Let's see how this chaotic cloud of what used to be our moon could transform itself into an elegant and orderly ring system.
This is where the beautiful, predictable nature of physics just takes over. That massive cloud of debris, our former moon, isn't going to stay chaotic for long. It's going to start to settle down into a very orderly pattern, all governed by the basic laws of motion and gravity. So, at first, all those fragments would just spread out along the moon's old orbit. But then, they'd start colliding. Countless collisions that cancel out any up or down motions. This process, it's called collisional flattening, and it forces all that debris into an incredibly thin disk. And then, over thousands of years, that ring would slowly widen out, a little bit like watching honey spread on a plate.
So, a beautiful new ring system for Earth. It sounds pretty amazing, right? Well, let me tell you, for anyone actually living on the surface of the planet, the consequences would be nothing short of apocalyptic.
Let's just start with the tides. As the moon gets down to that fluid Roche limit, the tidal forces pulling on Earth's oceans would become, get this, over 9,000 times more powerful than they are today.
And what does that actually mean for our oceans? It means the theoretical height of our tides would swell from a few meters to over 3,000 meters. That's more than 3 kilometers high. Twice a day, kilometer-high walls of water would just surge across the continents, completely reshaping the entire planet.
This table really puts it all into perspective. Just look at that column on the far right. Our current tide strength is 1x. At that fluid limit, boom, it's over 9,000 times stronger. And what if the moon somehow made it all the way to the rigid limit before breaking up? The tides would be over 66,000 times more powerful. And look at the orbital period. It drops from 27 days to just a few hours, meaning these monster tides would be happening way more often. And the oceans are just the beginning. The sky would be on fire with a constant, intense meteor shower as debris from this new ring rains down on us. The solid ground beneath our feet would stretch and groan under what are called solid tides, triggering massive earthquakes and volcanic eruptions. Oh, and the ring itself? It could block sunlight, plunging the planet into a completely new and unpredictable climate.
Thankfully, this is all just hypothetical for Earth. But, and this is a really big but, it's not just a thought experiment. The universe has actually shown us that tidal destruction is a very real and a very powerful cosmic force.
We've seen it happen. Back in 1994, we watched as comet Shoemaker-Levy 9 was ripped into a string of pearls by Jupiter's gravity before it smashed into the planet. Today, we look at Saturn, and the leading theory is that its magnificent rings are just the leftovers of an ancient moon that got too close. And for the future, Mars's moon Phobos is predicted to suffer this exact same fate, forming a brand new ring around the red planet in a few million years.
This quote just perfectly captures the leading theory for Saturn. It suggests a process of mantle stripping, exactly what we talked about for our own moon, where the outer icy layers were peeled off to form the rings we see today, while the dense rocky core was lost. It really is like the ghost of a world that once was. And that brings us right back to Earth. This entire process would transform our constant, familiar companion in the sky into something both beautiful and absolutely deadly. It's just a powerful reminder that the universe is an incredibly dynamic place, where even the things that seem the most permanent can be completely reshaped by the fundamental forces of gravity.